Hi, welcome to It's Not Obvious Java Edition for Mac OS X, and today I will be talking about variables. Specifically, the prerequisite for this episode is to watch a previous episode I had already uploaded that has to do with statements, expressions, and comments. I will do a brief recap in terms of values and expressions because you do need to know how that works in order to understand this episode. That said, the overwhelming focus for this episode is going to be about variable types, declaration, and assignment statement, which has to do a little bit with primitive versus non-primitive variables and how that work. Not going to go a lot into it. My focus will primarily be on primitive variables for this episode. I will also talk about how expressions and variables work together, as well as how things work in the background in terms of values and expressions, and how that ties into variables overall. This episode is intended primarily for my CSS 142 students at the University of Washington. That said, if you're new to Java programming or if you're new to programming overall, you might find this episode useful in terms of how variables are used, as variables are really the backbone, one of the very key components in terms of programming and getting anything done in programming at all. If it matters who I am currently a part-time faculty at the University of Washington, and during the day, I am a software manager at Amazon. Specifically, I work in AWS Kumo. If you want to know more about the kind of things that I've done, or if you want to get in touch and stay in contact, please find me on LinkedIn and connect with me there. First question that I want to address is this programming? And the short answer is yes, kind of. It's really only the very beginning of the very basic tools that you're going to use for Java programming. Specifically, how you're going to use variables, how you're going to use expressions, statements, and assuming that we have enough time, I'm going to do a brief introduction to functions. Specifically, if we were to look at the acronym that I introduced previously, which is the PET acronym, Problem Solving, Engineering, Tools, and Terminology, this is still on the tools and the terminology portion of things. This is not yet on the problem solving and engineering, which you need all of these things in order to properly write a program. All right, that said, let's get into variables. What are variables? Variables are a temporary container for a very particular value. And these values must be assigned, must be put into this container by what we call an assignment statement. Now, in order to work with variables, you need to know variable type, which defines what kind of values it can contain, and variable name in order to have some arbitrary label for the container itself. A variable must be declared before it can be used. Using a variable means to have some sort of value assigned to it and being able to look up that value again. And an example variable declaration is kind of like this. This is the variable type, which is a string. This is the variable name, which is just some arbitrary name that you give, and the semicolon that indicates it is the end of a statement. All right. So in terms of variable types, I will be focusing today on primitive variable types. There are actually a bunch of primitive variable types. The more common ones that you will be working with are ints, double, char, string, and boolean. An int is intended to store whole numbers. It cannot store anything other than whole numbers. In fact, if you're trying to put letters or decimal point into an integer, it's going to give you an error message, and I'll demonstrate that later too. A double can store numbers with decimal points. A float is also similar to a double, which is used to store decimal points. Float really stands for floating point numbers, which has to do with the period and the numbers following after the period. A char stands for character, stores single letters or numbers or special characters, but either way, it stores just one thing. A string, on the other hand, stores any length and combination of letters, numbers, special characters, and a string is kind of a primitive. It's really not exactly a primitive. It's actually what's called a character array. And in other words, what it means is that it's a character followed by another character, and so on to form a long string. And of course, you also need to work with booleans, which is an interesting data type, a variable type, because a boolean can only store true or false. It can only be true or false. It cannot be anything else. There are also other primitive variable types, which are short, long, and byte. If you go into this link, you will be able to see what it is, how it can be used, and so on. Keep in mind that Java is also what's known as a strongly typed language, meaning that in general, you're going to work with variable types with most values that you're going to be working with. There's also what's called a reference data type, or also known as a non-primitive variable type. By definition, a reference data type or a non-primitive data type is literally just any variable type that is not primitive. And the possibilities are actually endless, which is something I'll talk about in the future, but for now, I will be focusing on just primitive variable types, specifically int, double, char, string, and boolean for this episode. Now, before we go on, I also want to go over variable names and conventions. Keep in mind that when you create a variable, when you declare a variable, the variable name cannot have any spaces in it, but it can be most anything that you want other than very specific reserved keywords. And those reserved keywords, if you try to use them, you'll find out very quickly because the compiler is going to complain at you and you're not going to be able to use it. If you want to know ahead of time what those reserved keywords are, please feel free to go to this documentation that says what the keywords are that you cannot use for variable names. You also need to keep in mind that a variable name, the capitalization absolutely matters. If you use the wrong capitalization, or if you already declared the variable name with a particular capitalization and when you try to use it again, you use a different capitalization for the variable name, the computer is going to complain at you. It's going to say, hey, this doesn't exist because it's the wrong capitalization. It's actually not going to tell you something that specific, but essentially that's what the error is. I'll demonstrate that too in a moment. In general, a variable name should be descriptive. It should be something that describes what the variable is intended to be used for, what kind of value is intended to be stored in it. So for example, a variable name could be my address, it could be color, and it could be is valid. So you can imagine that my address is probably some kind of a string that stores some combination of numbers and letters that shows you what an address is. A color could potentially also be a string, although it doesn't necessarily have to be, because a color can also be represented by numbers, for example. So it could be a string, could be an integer, could be something else. Is valid, you can probably imagine that the answer to a variable called is valid is either true or false. So more likely than not, a variable named is valid is going to be a boolean. Either way, the idea is you want to follow a consistent convention, and typically people will use what's called a mixed case convention, where you have the first letter of the variable name in lowercase and then every single first letter of subsequent words to be capitalized. And this is because you cannot have spaces in variable names, and it's useful to have some differentiation between one word and the next word. If you are the kind of person who wants to know what the conventions are, what the recommendations are, and again, conventions are really just recommendations. Ideally, you follow something consistent. The recommendation from Oracle, the people who created Java, can be found in this link. Okay, and last but not least, before we go into the code demonstration, I also need to talk about assigning values and also talk a little bit about expressions. Variables can only contain values for its very particular type, and the values are assigned into the variable using the equal sign. Now, there's also such a thing called casting, which has to do with converting one variable type to another variable type. There's implicit casting and explicit casting. I'll try to touch on that today, but more likely than not, you're going to have to explore with it and play with it in future episodes. All right, so remember also, assuming that you know what expressions are, remember that expressions are really just a bunch of things with operators in it that becomes one particular kind of value. And if you have a variable equals some sort of expression, what's stored in the variable are the values that the expression has already evaluated instead of the expression itself. And I'm going to demonstrate what this looks like, and you do need to know the difference on this. Now, it gets a little bit weird. An expression can contain a variable. The computer is intended to look up the value of the variable. The value of the variable is used in the expression, and the expression becomes itself some sort of value. This means that a variable can be assigned an expression containing itself, which I have a slight humor type thing in the next slide, which I'll get to after I get through the code examples. All right, so this is BlueJ. BlueJ is an IDE that I use for these examples because my CSS 142 students, especially the ones who are new to programming, are typically recommended to use BlueJ because it's a simple IDE. It's a simple way to work with Java, that has some functionality in it that are useful. So as always, we open BlueJ and then we create a new project. The project name can be anything you want, as with a previous episode. And in fact, the project name could contain spaces if you want to. It doesn't have to, but it could. So I'm going to go var demo. And then you do need to create a new class in order to work with the code. And here I'm going to create a new class, and unlike the project name, the new class the class name cannot have any space in it. So I'm gonna do var demo again, and as before, BlueJ auto magically creates a whole bunch of stuff that are not particularly useful for you at this point in time. But eventually it's going to be useful, and you're going to understand what all of these means and how to properly use them. To begin with, there is a block comment that I talked about previously. We don't need that for now. There's also an inline comment, which is something that begins with this // and that's something that I'm going to use a lot in the current episode as well as future episodes. Then there are a whole bunch of other stuff, such as this private integer x, and then a constructor, an example method, which we're not going to use right now. I want to also point out that class is inside of this box, this green box, that shows you what the scope is, and it also has to do with this block statement, multi-line statement that begins with a curly bracket and a closing curly bracket. And you'll notice that var demo and sample method also have that block statement kind of a look, and it has its own yellow boxes associated with it, independent. Well, it's inside, but it's independent of the green box outside. You'll also notice that this private int x is not in any box at all, as well as this x equals 0. And this is an example of an assignment statement. This is actually an example of a declaration. For now, we're not going to use private just yet. I'll talk about what private means in the future, but for now, we're not going to do that. Instead, we're going to get rid of all of this, and we're going to begin with public static void main string array args. Open and close curly brackets, opens up this block statement. Main is now a method that we just created, and it has its own block. It's a yellow block, and we can compile this if we want. Now, there's nothing inside of main just yet, so if we try to run it, nothing really happens. In order for something to happen, we do need to print something to the screen so that we can see what's happening. So previously, what I showed you was to do system out print line hello world. And this is something that I like to do whenever I start something new, just to make sure that I can compile, just to make sure that I can run it, and make sure that it works the way I expect it to. And in this case, yes, it shows us hello world. Awesome, great. Now let's get into the different types of variables. We have int, and int is intended to store numbers without any decimal point. So I'm just going to say int num. That's a declaration. Let's see, what else did I have to do? We also have double, char, string, and boolean. Now, the pattern is exactly the same. You begin with variable type. And just to make sure you don't get confused, I'm going to do variable type, variable name, and semicolon. This is the pattern for declaring variables. So if we want to declare a variable of type double, we do double, and let's say decimal number. And notice here I'm using the mixed case. The first letter is lowercase, and the next word, the first letter, is uppercase. Okay, so we also have char, string, and boolean. So let's do that. Char C, just some sort of a letter, and string message, and boolean, let's say, is acceptable. And remember, boolean is only either true or false. Okay, now as far as naming goes, you can have as many different names as you want, and in fact you can have multiples of these variables, as many as you would like. So for example, I can have int num2, int num3, and you can also have int age, int x, int I, oops, I forgot the semicolon there, and of course you do need the semicolon, you can have int y, anything you want really when it comes to the variable name. Now, there is another limitation in that you cannot have two variables having the exact same name. So let's say if I were to do double num, it's going to complain here and it says variable num is already defined in method main Java lang string. So within the same method, in this case we're working with the main method, within the same method you cannot have multiple variables with the exact same name. So this has to be a different thing. Let's say decimal num. Okay. Well, now it's no longer complaining and we can compile this successfully. That going away, the diagonal lines going away means that it was able to compile successfully. But again, if we were to do double decimal number, it's going to complain again that says decimal number is already defined in the method main. It doesn't matter that it's the same variable type or a different variable type. If you have the same variable name, it's not going to let you within the same scope within the same method. Now, when we get to multiple scope, multiple methods, the rules change a little bit, and I'll get to it there when we work with it. But for now, keep in mind that basically when you declare different variables, it needs to have different names. And you can do double D, you can do char C, you can do char CX, char numC, anything that you want. The variable name doesn't really matter. It can be completely arbitrary, anything that you want. Same thing with string message. It can be string s, string name, string, anything you want. Again, the limitation is you cannot reuse a variable name within the same method, but other than that, most anything goes. Now, Boolean variables is interesting because Boolean is intended to store only either true or false. And remember that the general guideline is that a variable name should be somewhat descriptive. So a lot of times people have found that if you're working with a Boolean where it's either true or false, to use is as a prefix for the variable name, where in this case we say Boolean is acceptable, or we say Boolean is a number, or Boolean is valid, or Boolean is message length proper. Whatever you want, really. It can be anything. Now, so far, all we've done is declare variables. We haven't assigned any values to it just yet. And in fact, if we don't assign any values to it, and we try to print the content of the variable, let's say system out println num, it's going to complain at us. It says variable num might not have been initialized, meaning that num was declared, but no value has been given to num just yet. It goes, are you sure you want to do this? I'm not going to let you do this, in fact. And that's why you see this cross X thing for var demo that is in red. And also, if we try to compile, it just gives us the error again. It just really doesn't like that. So we need to assign some sort of value into the variable. How do we do that? We can assign the value by giving the variable name and the equal sign and some kind of value. Now, num is intended to be a number without any decimal points. So let's say num equals 10. Now we have two print statements. We have a print statement here, hello world, a whole bunch of declaration, an assignment statement, and another print statement. Let's see what happens. We compile this. So far, previously we had hello world. When we run this, now it's going to say hello world and 10. Now we have num equals to 10. We can change this to anything we want really, as long as it is a number. We run this and now it prints 99. It can also be a negative number, negative 999, compile, run, shows negative 999. But we cannot give a string into it, even if it is intended to be a number. It says incompatible type. Java language string cannot be converted into an int, cannot be converted into an integer. Now, you might think that for humans, this is pretty straightforward. For computers, this is actually pretty complex. And that is actually an interview question that sometimes is asked of candidates for a software development job. How do you convert a string into a number? As it turns out, it's not particularly trivial. Another thing that you could try is to give it some sort of a decimal point. Let's say 99.3. Again, it complains, but now it gives you a different error message. It says incompatible types, possible lossy conversion from double to int. Now this tells you that the computer recognizes that 99.3 is intended to be a double instead of an integer. So it still doesn't like that. But we can actually go to decimal number equals 99.3, and it is going to be perfectly fine. All right, now if we were to compile this and we were to run this, it goes hello world, which is our first print statement, hello world. Second print statement prints the value contained in num, which is 9, which is great. And then we declare double variables, and then we assign the value decimal number 99.3. But wait, how come 99.3 isn't showing up here at all? Well, the main reason why 99.3 isn't showing up at all is because we have a variable declared, we have a value put inside of that variable, but we didn't print it to the screen at all. So the computer's doing a whole bunch of stuff in the background, but you don't get to see it unless you do something intentional that tells the computer, hey computer, show me this. And in this case, we can do system out print line decimal number. And if we do that, then all of a sudden we can compile and we can run this and we get 9 and 99.3. Now so far, I have been assigning values on the exact same statement. But what happens if we were to say num equals 13 underneath num equals 9? So this is another assignment statement for the same variable num. Okay, well, let's compile and let's run this. Now we see hello world 13 and 99.3. Well, what happened to 9? At some point, the value of 9 was assigned into num, but we never got to print it because before we printed it, the value of num is changed to 13. All right, so I'm going to use this thing to illustrate what that looks like because I'm going to go into it a little bit more later on too. Here, in this case, we have a variable type, integer, the variable name num, and the value initially is 9. When we go into line number 18 here, the value is 9. When we go to line number 19, when we execute this statement, num equals 13, the computer goes to here and goes, oh, I have a variable, an integer variable called num, and the value was previously 9. I'm going to get rid of that, and now the value is just 13. And by the time we print out the value of num, it looks up the value, which is just 13, which is why it printed out only 13 and not 9. And you can do this a whole bunch of times. You can do num equals negative 99, for example. And then what happens is it goes, well, previously num is 13, but now we're saying negative 99 is something that needs to be put inside of num. So now the value is negative 99. Cool. The computer doesn't really care why you're doing this, but when you execute it, it just looks up the value and it prints out whatever the value happens to be at that point in time. But now what happens if you say num equals 101 after you print it? You compile this, you run this, and the value that's printed onto the screen is still negative 99 instead of 101. After this line is executed, the computer actually do update this to say 101. But after this line where the value of num is changed to 101, there's nothing that prints the value onto the screen. In other words, in order for you to see what's happening in the background, you do need to tell the computer to show you very, very explicitly. It doesn't just automatically go and updates negative 99 to 101 because you changed it after you printed it. It simply looks up what needs to be printed right at that moment, and it prints that. Whatever you do with that number afterwards, whatever you do with that variable afterwards, the computer doesn't really care. It just does whatever you tell it to, but it doesn't update what's already been printed. Okay, unless you very intentionally tell the computer to do so. So now we compile, we run this, and the first time it prints num equals -99, and the second time it prints num is 101 after all of this. So same thing also when it comes to decimal number. Decimal number equals -33.3. You can do exactly the same thing. And just like before, decimal number, and actually I'll do this over here too, double decimal number. First you declare it and the computer creates an entry for the variable. It goes, initially it's 99.3, it goes, sure, that's fine, 99.3. The next line it goes, okay, now it's 101.1, cool. And the next line it goes, -33.3. It just continues to update this variable. The value of this variable, it reuses the variable because that's what a variable is intended to be used for. It's intended to be a temporary storage for some sort of value, and it's intended to be reusable. Okay, cool. So just to wrap it up a little bit more, you can also create, for example, C equals A. And you might be a little bit confused here because C equals A. A is obviously not C. Again, there is a distinction between the variable name and the value that's stored inside of it. So here we have char, C, and the value is just A. In fact, the value can be any letter. Let's say C equals to 5, and the computer will still allow that. It doesn't really care what value you put into it, even though it's not C. The computer looks at the value of a variable and the variable name as completely distinct. It's up to you what the variable name is, and it's also to some extent up to you what the value is, as long as the value matches with the char, with the variable type, in this case char. Okay, and in fact, this should be 5 as in a letter 5, a character representing 5 instead of the number 5. String, same thing. We have message equals hello there. And notice that for a single character, we have single quotes, and for a string, which is multiple characters, we have this double quote. All right, and Boolean, let's say is acceptable equals true. You can also have is a number equals false. All right, so these are the only two possible values for Booleans, true or false. That's it. Let's look at a few other things that are kind of interesting. First of all, you could actually, during the declaration of a variable, assign a value into it directly. Like in this case, we have num2 equals 10. Previously, we declared num first and then give the value in a separate assignment statement than the declaration. You don't necessarily have to. You could give the value directly when you declare the variable. In this case, now I'm going to change this out a little bit, where the first one prints out num, and the second one, I'm going to have it print num2. Compile, run, great, and where did that window go? This is another thing that happens when it comes to BlueJ, especially if you're on a Mac. Sometimes the window that shows you what's happening gets hidden in the background and you need to go find it. Hello world, -99, 10, -33.3, and so on. Okay, now we know here that -99 is num, even though it gets changed to 101 after we print it to the screen. And the second print statement simply prints num2. And notice that we didn't assign a value to num2 anywhere other than the declaration. And even if you include the value when you declare a variable, you can still change it whenever you want. Num2 equals -33. Compile. Run it. And you get -33 as the value of num2. Okay. Now, here's another interesting question. What happens if we give a whole number without any decimal point into decimal number. Okay, so for now, because 99 is the first number that is assigned to decimal number, and we change it a couple of times before we print it, the thing that's printed onto the screen itself hasn't changed because it's negative 33.3. But notice that there's no error. Whereas earlier, with number, if we were to add a decimal point, it complains immediately. All right, so let's see what happens. Let's say if we were to convert negative 33 to negative 39, just a whole number over there, and then print it out. Compile, run, and what you get is negative 39.0. And in fact, we can make this a little bit more obvious. If we were to do decimal number, negative 33, we run this, and there is a distinction between printing an integer that contains the number negative 33 or a decimal, a double that contains the number negative 33, because the int is simply displayed as negative 33 and the decimal number, the double, is displayed as negative 33.0 to indicate that this is a double. This is not an integer. Okay, great. So let's do a couple more things where we have message and we have Boolean. Now, another thing that you could do, and I'm just going to clean this up a whole lot in order to make it a little bit easier to see everything. Let's say you have an integer num equals 3. And then you have system out print line, and you can say num is plus 3. Compile, run, and you get num is plus 3. And this is something that I showed you previously, which is an expression. This is an expression. You have some sort of value, and you have another value, and you concatenate it together as a string concatenation that prints num is 3. Now, that said, num is not necessarily 3. Num could actually be 10. And if we compile this and we run this statement is now wrong because the statement says num is 3, but it's not anymore. Num is 10. So the way we do this is we put the variable name inside of the print statement inside of an expression. So what this is doing is the computer is going, oh, well, we don't have this char and double anymore, so let's get rid of that. But now we have num, and the value in here is 10. So the computer goes and looks up the expression. Num is plus num. And so it goes, num is 10. Num is plus 10. Because at this point in time, whatever is inside of num is 10, and that's what gets shown over here. And if we compile this, and then we run this, now it says num is 10. And at this point, anytime we change the value of num and we run this expression, we're going to have the same response. Let's say num equals 100, compile, run this. We go num is 100. Again, we go num equals negative 99. Cool, compile, run, and num is negative 99, because now the computer just looks up whatever num happens to be when the expression is evaluated, and it prints that. Okay, well, now I just showed you how you can put an integer variable into an expression. What if we also have a string variable? String message equals num is. And instead of num is, we go message plus num. Same thing, we can run it and we can say, hey, num is negative 99. Now, you'll notice that there's a slight difference because now we're missing the space after the colon. We can add it over here, and in fact, we can say the variable num, and let's say single colon currently contains the value colon, and that is the message. We can compile this, we run this, and the message is now different. It says the variable num currently contains the value -99. Okay, now you see this expression of combining a string variable and an integer variable. Combine string variable plus int variable, and then we print it. Okay, cool. Now it gets a little bit interesting. Now this is the point where I go into this next slide. This is something that I saw a while back, and I thought that it was really interesting because I've been a programmer for a long time. I've done a lot of math, and probably because I've been a programmer for a long time, this expression makes sense to me both from a mathematic as well as programming kind of perspective. But once I saw this comic, this joke cartoon, I realized why it gets really confusing for people sometimes. Okay, so why does it get confusing? When you have x equals x plus 1, a mathematician typically looks at this as something to solve. You're trying to solve for x. And if you're trying to solve for x, what you're going to do is you're going to take x equals x plus 1, and you're going to do x negative x, and here x plus 1 negative x, which means that you're going to end up with 0 equals 1, which really just doesn't make sense at all from a mathematical kind of perspective. In fact, it can be anything we want, right? Like let's say x equals x plus 7, and here we end up with x minus x equals x plus 7 minus x, and you go with 0 equals 7, and it just makes no sense whatsoever. Okay. On the other hand, what happens with a programmer is we look at x equals x plus 1 semicolon as a statement. This is a statement, and the statement contains an expression. The expression is simply x plus 1. Well, let's take a look at what that means in BlueJ. All right, so let's say we are printing out system out println num plus 10. So we have a couple of print statements. Hello world, the variable num currently contains the value -99, and now we print num plus 10, and now it's -89. Okay, well, this is an expression, and that expression becomes a very particular value, and that value can be stored inside a variable. Let's be a little bit generous and say int y equals num plus 10. At this point, it should be somewhat obvious that this is an expression. Stores the value of num plus 10 into y. Now, instead of printing num plus 10, we can print y instead, and we can compile. We can run this, and you can see that it is still -89, and we can change what this expression is, and we can say plus 13, compile, run, and we go, all right, so we can understand how this expression works, how it's stored into this other variable y. But we can also do this. Num equals num plus 13. Because at the same time, we're really just storing the expression. We're looking at what the expression is. It becomes some sort of value, and we store that value instead of num. Okay, so what does that look like in the background? We have num. Oh, and first I'm going to fix this so that it says num because we no longer have y. Cool, compiles okay. So first, let's come up from up here. We declare num, and we put the value as 10. And then we have num equals 100, which is the next line. And then we have num equals -99, which is the next line. And then we have this string message And this is a whole bunch of string. I'm not going to copy and paste it for now, just for the sake of time. And then we print out message plus num, which is an expression, message plus num, and this is whatever the string was, plus whatever num happens to be at this point in time, which is negative 99. And then we have this other expression, num plus 13. So we have num plus 13, and the value is whatever the value of num is at that point in time, negative 99, plus 13, which means negative 86. Okay, cool. Which means that by the time we assign the value of num plus 13 into num, we take negative 86, we put it in here, which is why we print out negative 86. Okay, so that is one way that you can think about variables. That is one way you can think of expressions. You need to keep track of what the variable type is, what the variable name is, what the variable value is, and same thing with the expressions, the values retrieved, and the processed value. Now, another question that typically comes up at this point is, hey, this is great. We're working with variables, we're working with numbers, we're working with different values, but everything is something that you as the programmer has to put in yourself. How do we get input from users? So getting input from users, unfortunately, is not all that straightforward. Getting input from user, which is going to be my next episode here, you do need to do import java util scanner. And again, keep in mind that capitalization does matter. And then you have to create what's called a non-primitive, a reference type variable, a scanner variable, and let's say scanner user input equals new scanner system in. And then instead of having num equals negative 99, you would do user input dot next int. And what that looks like is you'll end up with something like this, and it says type input and press enter to send program. And let's say we do 300, and then it goes whatever the user input is, which in itself is actually an expression. It gets a particular value, and that value is given by the user. That value is then put instead of num, and in this case, we say the variable num currently contains the value 300, and num equals num plus 13 is just whatever num was at the time this line was executed, plus 13, which means that num is now 313. Okay, great. So that's basically it for today. As always, my question to you is, what were some things that were obvious to you, and what were some things that were not obvious to you? I hope that you learned something new in this episode. And if there are additional questions, if you're in my class, definitely ask me. If you're not in my class, feel free to ask me in the comments, and I will try to explain in the comments, or I will simply create a new episode that goes into those topics a little bit more. As always, if you like this episode, or if you're interested in future episodes, please like the episode and subscribe for more content. Thank you very much, and see you next time.